Hey everyone, so in this video we're going to take a look at another 5 of the most difficult SAT math questions. These questions are from a real SAT, and when I did these questions, these were definitely the hardest ones that I came across. So if you can do these questions, you guys are in a very great spot for the SAT coming up. So let's start with this question. This question says that we have two numbers, A and B, and they're each greater than 0. So we'll start with just writing A is greater than 0, B is greater than 0, and it tells us that 4 times the square root of A is equal to 9 times the cubed root of B. Then it tells us that we're looking for if A is equal to 2/3, so basically when A is equal to 2/3, then for what value of x is a to the x going to be equal to b? Or in other words, at that value of a, when we're at 2/3, 2/3 to the power of what will be equal to b? And we can tell from this equation up here that it tells us, right? 4 square root of a equals 9 times the cubed root of b, is that when a changes, b also changes, right? So it's giving us this value of a of 2/3, and we want to figure out what that value of b is first, so then we can determine what the value of x will have to be. So, well, okay, 4 times square root of a. Let's rewrite our exponent in, just because it's a little, we've got cubed roots and we've got square roots, so let's write them in exponent form to make it a little bit easier to see. We've got a to the half, or I should write this, let's say 2/3, right? Because this is when a is equal to 2/3, right? And then this is equal to 9 times b to the 1/3. Okay. We can divide out, we've got coefficients on both sides, and what we can see here is that if we do end up dividing both sides by 9, we'll get 4/9 times 2/3 to the half is equal to b to the 1/3. And the trickiest part of this question, I would say, is realizing that this 4/9 is actually just 2/3 squared. And the reason that we want to express this as 2/3 squared is because now you can see we have the same base and different exponents, but they're being multiplied by each other. So this should be right away indicating that we can use an exponent law, right? And when we multiply things with the same base and different exponents, we add the exponents. So 2 plus a half is 2.5, or in fraction form, that is 5/2, right? So we've got 2/3 to the power of 5/2 now. And this is equal to b to the 1/3, right? Recall, we're solving for this value of b right now, right? And ideally, we want to keep our 2/3 in our equation, because if we can keep that 2/3 and have it to a single exponent, well, then we can very easily see what our value of x is. So let's scroll down, okay? And you can see we're actually very close to that form right now, right? And to isolate for b, we just need to take both sides to the exponent of 3. And remember, when we have an exponent to another exponent, that's just multiplication. We're not adding there, right? We only add when we multiply two different bases with exponents. When we have one whole side, like 2/3 to the 5/2, and we're raising this to the exponent of 3, then we just multiply, right? Okay, so 5/2 times 3, multiply 5 into the numerator, or sorry, 3 into the numerator, so 5 times 3 is 15. Denominator stays the same. And then we've got b to the exponent of, right, this is 3/3, which is just 1, right? So now we can very clearly see, right, well, this is just like what we started with. A is 2/3, right, in this case, right? And this is equal to b right now. And we can very clearly see now that for that value of x when a is equal to 2/3, if we have the equation ax equals b, in that case the x has to be equal to 15/2. So I'll write therefore x equals 15/2. Right? You can write a more complete statement, but that's not the purpose of this video. So let's move on to the next question. This one's a bit wordy, and it's easy to get stumped or confused on the wording of this question. It says the value of r is 20/21 times the value of t, where t is greater than 0. What value of t is what percent, or the value of t is what percent greater than the value of r? So let's write what we know here. We know that r is equal to 20/21 times the value of t. Times the value of t, right? And it's implying here that t should be greater than r. So let's plug in something and check, right? So let's choose something easy like t is equal to 1, right? When t is equal to 1, then r is 20/21, which is very clearly less than 1. So we can see, yes, t is a little bit bigger than 20/21, right? Because we're only 1/21th or 21st larger, right? So when we're trying to find percent greater than r, right? Well, that's just going to be t divided by r. And if that doesn't make a whole lot of sense, well, take two numbers, right? 2 and 1, right? Well, clearly if I asked you how much greater is 2 than 1 as a percent, well, you could say it's a whole 100% greater than 1, right? If we start at 1 and we add 100% of 1 on top of itself, we will get to 2. And that makes sense, right? So if we ended up doing 2 divided by 1, this is going to get us with 2, or 200%, right? Which we can then interpret and say, well, 200%, that is 100% greater than 1, right? Because we're looking for the difference there, right? The difference between 200% and 100%. So in this case, when we have t over r, okay, we've got 1/20/21. And this is equal to, right, just 21/20. Multiply both sides by, the numerator and denominator by 5. We end up with 105/100, which is very clearly, we can see from, right, as a percent, this would be 105%. And this makes sense, right? We said that, t is only 1/21st greater than r, right? It's just a tiny little bit bigger. So when we're looking at our result, right, and it's asking us what percent greater than the value of r, it should only be a little bit, right? So it makes sense that we should see that it's only 5% greater, right? 105% would imply quite a large difference, right? But we know between 1 and 20/21, it should only be a little bit. So when we interpret our result, we should be able to fact check here and see, yeah, the difference between t and r as a percent should just be a small amount. And we can see here that it would be 5%, right? 5% on top of 100%. So the difference and I'll write this one fully. We'll say the difference, gotta make some space here. The difference, or actually, let's write this better. We can say that t is 5% greater then R. Okay. And you could have chosen some other numbers too, but t equals 1 is quite an easy one to work with. So let's move on to the next question. 36, it says that, okay, we've got this minus 9x plus 24qx equals 36, and it says that in this equation, q is just a constant. If this equation has no solution, then what is the value of q? If you're looking for the fastest way to solve this, I should be able to see that if I can make the value of q something that cancels out with minus 9x, then I'll get 0 on the left-hand side and 36 on the right-hand side. So, in order to have something that cancels out with minus 9x, that coefficient should be plus 9 that is on our second x term. So 24q should be equal to plus 9, right? And then q is equal to 9 over 24, or q is equal to 3/8. This would be the fastest way that you can solve this. And if you can't see that right away, that's totally fine. Let me explain it in another way. Okay? If you understand this method on the left, it's the fastest way, feel free to skip to the next example. But another way that you can think of this is, right, we've got this left-hand side. This is minus 9x plus 24qx, right? And we can see that this is just some linear function, right? I can rewrite this as minus 9 plus 24q. That is our coefficient, or our slope, that is tacked onto our x term, right? And our y-intercept would be, plus 0. And it's asking us, when is this linear function? Well, when is this equal to 36, right? 36, we can kind of represent this as just a horizontal line, right? So if we were to draw this out, okay, let's scroll down. If we were to draw this out, we can see that 36 would be something like this, right? Y equals 36. Let's label our axes, y and x. Well, that linear function, it depends what it looks like based off of q, right? And let's put this in green, right? So it could look something like this, right? And it would intersect there. That would be a solution. Maybe it has a negative slope, right? If it had a negative slope, then its intersection would be somewhere in that second quadrant, right? Something like this, right? And depending on that slope, it will have a different solution. But the only time that it has no solution is when that slope is equal to 0. And when that slope is equal to 0, right, it's going to be just a horizontal line across the x-axis, right, or 0. And we know that the slope, right, we already saw that that slope is equal to minus 9 plus 24q. And when that equals to 0, right, then we just have 24q is equal to 9. And then you can see this is exactly where we started. This is exactly where we started on the other side, right? Noticing algebraically that it should be equal to 0 on the left-hand side. And you'll end up with the same result, right? So hopefully that maybe gives you a bit more intuition on why that left-hand side has to be equal to 0. So let's move on to the next one. It says that a company spent a total of $9,000 on digital and print ads, and the ratio of the money spent on digital ads to money spent on print ads was 1:3. So that means that every time that this company bought or spent money on a digital ad, it means they spent 3 times that amount on a print ad, right? So we can kind of think of it as like these groupings of 4 ads all together, right? So like if we were to represent this as like a cost function, right? Cost of our dependent variable, let's call it ads, right? Our independent variable, sorry, ads, right? That would be, okay, for every 1 print ad, well, we also are going to spend money on 3 digital ads, right? So this is the 1 digital ad to 3 print ads, right? So when we add these two add costs together, then that's going to give us the total cost, right? So I should write here, digital cost, print cost. This would be our total cost. So if you can set up this, then the question's pretty straightforward actually, right? It's just, it's not always super clear that we should write this function like this right away, right? Because we see this ratio of like 1 to 3, and it can be a little bit challenging. And you know, you could also figure this out just by kind of guessing and checking, right? And doing like, you know, let's say I spent $1,000 on a digital ad. Well, that means I would spend $3,000 on a print ad. So the total, right? Total would equal $4,000, right? And you could keep on doing this, right? Until you find the total being 9,000. But the fastest way to solve this would definitely be to create a function on our left-hand side and then setting our total cost equal to 9,000, right? So if we do that, we see 9,000 equals 4 times A, right? We're just adding the digital and print cost because 4A would be our collected like terms. And then dividing this out, we can see 9,000 divided by 4 would be equal to, well, that would be 4,500 divided by 2, which is 2,250, right? $2,250. And remember, this question is asking us how much did they spend on digital ads. The digital ad cost from our function, right, is just 1A. And we can see we actually just solved for 1A, right? By solving for A, we actually solved for 1A. So we can conclude that this company spent $2,250 on digital ads. Finally, let's go to the last question that I have, and this is probably the easiest one. But again, there were really no other harder questions than this on the SAT. So this one gives us a quadratic, and it tells us that a solution is given by the square root of k minus 1, and it asks us what is the value of k. We can see that we can't really factor this quadratic right away, because quickly, if you try to figure out what adds to 2 and what multiplies to -1, we're not going to be able to come up with any nice integers that do this. So that should be an indicator that we are solving for the quadratic equation, or using the quadratic equation. I'm also just going to write here that since we know that one of our solutions is the square root of k minus 1. So using quadratic equation, we get minus b, which is minus 2, plus or minus the square root of b squared, so 4 minus 4ac. I'm trusting that hopefully many of us are comfortable with the quadratic equation. This is all over 2a, and this is just algebra now, right? We can get minus 2 plus or minus, this will be square root of 8 over 2. Just a quick aside, we know that the square root of 8 can be written as the square root of 4 times 2, square root of 4 times the square root of 2, which is then just 2 root 2, right? So I can now write x is equal to minus 2 plus or minus 2 root 2 all over 2. Bunch of 2's, so let's clean this up. Remember, we've got the addition or subtraction in our numerator, which means that our denominator, right, if we're dividing both these things, or both our terms in the numerator by the same thing, we can break up this fraction. And we can write this as minus 2 over 2 plus or minus 2 over 2 times the square root of 2. Okay, and we're almost done. Remember, we're trying to get it to look like square root of k minus 1. So let's move our square root term to the left side. We're not doing any magic here, we're just rearranging, right? So 2 over 2 is just going to be 1. Root 2, and then, sorry, this is plus or minus, I should include. And then this is going to be minus 1. Right, so we can now see our roots are going to be positive root 2 minus 1, and negative root 2 minus 1. And it tells us that one of these solutions is square root of k, positive square root of k minus 1. And down here I can see that positive root 2 minus 1 is a solution, right? And you can see, right, we're comparing these solutions, right? We can see that k is very clearly going to be equal to 2, right? So therefore we can say k is equal to 2. Okay, and that's about it for the questions. I hope you enjoyed this video. If you can comfortably do these questions and like you feel like you could do these without much guidance or without many hints, then you'll do excellent on your SATs and you have nothing to worry about. So I wish you luck in your studying and good luck on your SAT.